Hello, welcome to this presentation about reactions of halogens. My name is Joshua. We are going to look at different areas of reactions of halogens, and we shall be explaining every single step with the reaction equation, except those areas which may not necessitate any equation. So there we are. Reaction with water. We know very well that fluorine oxidizes water vigorously to produce oxygen and hydrofluoric acid. That's what we are trying to look at as of now. And the equation is just like that. So the water reacts with fluorine, and then the product is the Abel's gate of oxygen and hydrofluoric acid. Can continue. When it is chlorine and bromine reacting with water, they will always produce for you the halic acid, and then if it is, for example, chlorine, it gives you hydrochloric acid and hypochlorous acid. If it is bromine, it gives you hydrobromic acid and hypobromous acid. So in that particular case, the equation is representing that X is either bromine or chlorine. We are giving an example where it is really necessary. We go on. Iodine partially reacts with water to form an unstable compound, which actually quickly reverts back forming iodine. And in some cases, we actually say that there is no NCS reaction, since the unstable compound that is formed quickly reverts back in no time. But this same iodine is actually sparingly soluble in water, and but it is highly soluble in potassium iodide. The reason being that with potassium iodide, it always produces something called potassium triiodide. It's a complex, and you know very well that complexes increase the solubility of these insoluble substances, since you can easily tell that the reaction will shift so much to the right. That is our equation. With alkalis, in this case I mean sodium hydroxide and potassium hydroxide, we know very well that this takes place when you're having two conditions. One, cold and dilute alkalis, and another one is concentrated and hot alkalis. But I've said that the alkalis that we should be able to use in this particular case should be that is of sodium or potassium, just because for them they are strong and we are assured of the reaction. Cold and dilute alkalis. What do we get? Fluorine for it is special. It has a lot of anomalies, and it will always form for you oxygen difluoride, like you see in the equation, and it forms also the fluoride, and then it forms water. So if I'm to write, for example, the molecular equation, I will give the fluorine reacts with sodium hydroxide, for example, give us oxygen difluoride, sodium fluoride, and also water. Now with chlorine, bromine, and iodine, they will always form the halide I, and water, as that equation is suggesting, that X represents chlorine atom, bromine atom, or iodine atom. Moving on, if it is hot concentrated alkalis, still fluorine behaves differently. In this case, it will produce for you oxygen, sodium fluoride, and water, like I'm showing you. And if it is chlorine, bromine, and iodine, then we shall have now the halide 5. This time the halide 5, you know that is, for example, the chlorate, the bromate, and iodate, and of course still water. The equation is there. X is representing the chlorine atom, bromine atom, and also iodine atom. We can move on. Sorry for all those issues, but we can take now reaction with hydrogen. Fluorine can easily react with the hydrogen with a lot of ease. There is no need to put any conditions. So it explodes in dry hydrogen, even in the dark, to form hydrogen fluoride. When it is chlorine, it reacts vigorously with the hydrogen to form hydrogen chloride. That is in presence of ultraviolet light. Bromine, you can easily see that for it requires a lot of heating and in presence of a catalyst like platinum catalyst. And in this case, you see that the temperature is going to be around 200 degrees Celsius. If it is iodine, it is even worse. The reaction is almost impossible, and actually this reaction is very reversible. We expect the iodine to react with hydrogen at even higher temperature than even bromine, that is 400 degrees Celsius to hydrogen iodide, and the reaction is usually reversible, like you're seeing it in the presentation. We got something else, oxidation reactions. Chlorine, bromine, and iodine can oxidize. So now I'm ignoring fluorine because fluorine has got anomalous behavior, and we shall not put a lot of attention onto it, since we can easily lose even direction. Okay, thank you. We're going to move on, and we shall be stopping on to that oxidation reaction. I'll give a question which is related. Now, for example, if you react chlorine with tin salt, for example, tin 2 chloride, it will get oxidized tin 4. And then, of course, chlorine is going to be reduced to the chloride. If it is hydrogen sulfide, you know that iodine with hydrogen sulfide will form hydrogen iodide and sulfur. If it is bromine, you can easily see that there is no any big difference. Where there is I, you replace with Br. Okay, allow me stop here for this simple presentation, and don't forget to subscribe to my YouTube channel, Tumwine Joshua. So you check, you comment, you give all the directions. I promise we can use them to actually improve those presentations. You do not have to mind so much about the audio because there is a small issue and it's going to be sorted as soon as possible. Thank you very much.